afterwards for ABB, which is Swedish-Swiss electrics group. And you see here on top, this was a project I have done, bringing a prototype of this electronic differential currency circuit breaker into production, and the colleagues gave me this model with my picture printed on. After that, I moved to GMD, German National IT Research Center, and in 2001 I started Fraunhofer in Japan, and we did a lot of collaborations with companies. We presented, like here, this robot. We made contracts, memorandum of understanding with Sendai City, and also opened a research center at Tohoku University. This is actually for MEMS and NEMS devices. 2014, I moved to AIST, Sangyō Gijutsu Kenkyusho, here in Tokyo, and I also teach at Waseda University. I represented some German companies, and one of them since this year is Contact Software. I would go now to show a little bit about AIST, as this also has to do with our topic. So AIST, or Sansoken in Japanese, is a national research center with 10,000 people. We are into many different areas: renewable energy, life science, IT, materials, and so on. And we also have our Artificial Intelligence Research Center. That's where I am sitting. And here we also have a so-called Cyber Physical System Center, where we have machines and look how these machines are working and how artificial intelligence can control this. I was talking about Fraunhofer. So in Germany, Fraunhofer is a very big candidate for Industry 4.0, and here on the picture, this is from 2018, you see a delegation from AIST. This is a vice president, Dr. Sekiguchi, visiting Fraunhofer in Germany, the application center Industry 4.0. This was a little bit also to learn how to set up our own center, which just opened last year. Now, Contact Software, I want to give only some brief explanation. Contact Software is now 30 years old. It's a very agile company trying to adapt to the customer needs. The industries covered are pretty broad. There's automotive, there is high tech, even medical, consumer products, and so on. Altogether, more than 400 people staff, and more than 25% in R&D investment. And we have a global ecosystem. In Japan, the company GBS and Ken Iwamoto is a partner who will implement our software here in Japan. The main thing we are talking now today is digital twin, and digital twin is not only the geometry or some CAD data, it's much more. It contains basically all information you can get about a product and about the functioning of a product. So we have the topic Industry 4.0, Society 5.0. Industry 4.0 was actually introduced in Germany in 2011 as part of the German high-tech strategy, which also covers other fields like social areas that are included in the Japanese term Society 5.0. And the idea is that we have the first industrial revolution with mechanization coming from water or steam power, Then we have the second mass production, the famous assembly line from Ford. And the third was basically computer and automation. And now the fourth industrial revolution is actually about cyber physical systems. So cyber physical systems mean that we have the physical system, which is, for example, a machine tool. And then we have the cyber machine, which has all, not only geometry, but all functionalities of the original machine. And then we connect all those cyber machines, and then actually we have a cyber factory, which you see in the corner. And the cyber factory has actually all the functionality of your factory, and then it's connected with other factories, for example, suppliers or customers and so on. The whole structure of Industry 4.0 is actually described in Germany with the so-called reference architecture model, Industry 4.0 or RAMI 4.0. And here we have the basic architecture, which groups everything into the real items and the digital items. So the real are the things, for example, machine or factory and so on. Then you have some integration part, and then you have the communication module, you have the data module, you have the functions. So for example, machine is cutting metal, so the function is then cutting. And then on top you have the business process, and the business process of your company can be producing cars, for example. Here you see in the middle, you see this RAMI architecture. So here on the left side, you have this this architecture we mentioned. So the things, the integration, the communication, information, function, and the business. And in this axis, actually, you have the life cycle and value stream. So, for example, you have to buy the machines, you have to set up the machines, and then you can produce the product, for example. And on this axis, actually, here we have the typical hierarchy level. So, for example, starting with sensors and actuators. So this is here the field device. Then we have the control device. We have workstations. We have work centers, and then we have the company. And on top we have the connected world. And in the bottom is actually the product. So this is the classical product hierarchy, which I would like to show on the next paper. So this is the old model. It's very hierarchical. It's not connected. So you have different field devices, then you have different control devices, you have the station, you have work centers, and you have the whole company. And below you have the products, and they are not linked to all the other processes. This was Industry 3.0, and now we go to Industry 4.0, and here you have the smart factory, where actually everything is connected to everything else. We have then the smart, so this is the smart factory, which you have. So actually the left side triangle transformed into a smart factory. And then on top of that, on top of the enterprise, we have the connected world. So you're connected to other companies, to suppliers and so on. And so the whole value stream basically is built there. And here you have the smart products. And a smart product is characterized by also processing information and having sensor systems that give informations about the function and the status of the product. So simple example, you can make an electric engine which is in a machine tool, and this engine can be equipped with sensors which understand or which control the vibration and the temperature. So you get some information about the status of this engine or this electric engine, and like that you can, for example, see if there is some technical problem. And if this is inside the machine tool, then this information again helps the machine tool maybe also to detect some early warning signs of some technical problem. So these smart products are linked actually with each other, and this will be actually the future.